Welcome viewers. In this video we'll see the solved problem based on the short circuit admittance parameter coming under two-port network. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Solved problem. Short circuit admittance parameter coming under two-port network. The problem is find the Y parameter for the network shown below. Y parameter means admittance, short circuit admittance parameter. The network is given here. There are 4 resistors available, 1 ohm, 2 ohm, 2 ohm and 4 ohm. So the 2 port coming under 2 port network. The input port A dash is the input port. Input voltage is V1, input current is I1. B dash is the output port. V2 is the output voltage, I2 is the output current. For this network we need to find the Y parameters. The Y parameters mean it is a short circuit admittance parameter. Short circuit means the output port is short circuited and the input port is short circuited. For the first two parameter Y11 and Y21, we are short circuiting the output port. Output port is short circuited so that V2 equal to 0. Output voltage is 0. In that we are finding the Y11, that is I1 by V1, Y21 I2 by V1. This I1 by V1, so that is called a input admittance parameter. I2 V1, both input and output parameter available, so it is called a transfer parameter, transfer admittance, forward and reverse transfer admittance. In the second case V1 is 0, input port is short circuited. Then we are able to find Y12 and Y22. Y12 is I1 by V2. Y22 is I2 by V2. Here see both are output port, so that it is called a output admittance. This one transfer admittance. So by making V2 equal to 0, we can find first two parameter. By making V1 equal to 0, we can find another 2 parameters. Right. Now we'll go to the problem. So first we will consider B dash is short circuited. The output port is short circuited so that V2 equal to 0. Then the network is shown below. So the output port is short circuited. Here I2 is flowing, I1 is flowing, V1 input port voltage V1. These are all the resistors. This 4 ohm is short circuited, so there only 3 resistors are available. 4 ohm is connected across this, that is short circuited. Now with this condition we are able to find Y11 as well as Y21. What is Y11? I1 by V1 with V2 equal to 0. Now cross multiply this so that V1 I1 equal to Z equivalent. That is Y11 is nothing but 1 divided by Y1 is Z equivalent. So cross multiply this. So V1 equal to I1 by Y11. Y11 1 divided by Y11 is nothing but Z equivalent. That is admittance is nothing but impedance. Right. So by calculating the impedance, we are able to find the Y11 value. Right. What is the Z equivalent for this circuit? You have to refer from the input side, Z equivalent. So this 1 ohm is available. Here the current is diverted. That means these two are in parallel condition. So these two are in parallel, that is in series with the 1 ohm. Right. So Y11 equal to I1 by V1, V2 equal to 0. With cross multiplying we got V1 equal to I1 by Y1. 1 divided by Y1 is nothing but Z admittance. 1 divided by admittance is impedance. Right. So that is the equivalent impedance of this circuit. By finding this value we can easily find the Y11. So the Z equivalent referred from this side is nothing but 1 ohm. Here the current is diverted. So these two are in parallel, that is series with the 1 ohm. So the Z equivalent equal to 1 ohm plus these 2 ohms are in parallel. So 2 into 2 divided by 2 plus 2. That is equal to 1 plus 4 by 4. 4 by 4 is 1. So 1 plus 1, 2 ohm. So the Z equivalent is 2 ohm. So that V1 equal to I1 into Z equivalent. Z equivalent is 2. So bring this I in the denominator. So V1 by I1 equal to 2. But what we need is I1 by V1. So the reciprocal, take reciprocal on both sides. So I1 by V1 equal to 1 by 2. So this I1 by V1 is nothing but Y11. That is equal to 1 by 2 mho. Right? Ohm means resistance. Mho means that's impedance, that's admittance. Right? So Y11 equal to 1 by 2. That is 0.5. Value is 0.5. So by making V2 equal to 0, by finding Z equivalent, we calculated one parameter. The next parameter is Y21 equal to I2 by V1 with V2 equal to 0. Right. So here we need I2 value. I2 value is needed. By calculating I2, we can able to find the Y21. What is I2 here? Is I2 value. I2 current is flowing here. Here I1 is there. The I1 current is flowing through 1 ohm. At this point it is diverted. So by using current divider rule, we are able to find the I2 value. Right? So it is flowing in opposite direction. So minus I2. I1 is flowing this side, I2 is flowing that side. So minus. Right? So I2 value can be calculated by using the current divider rule. I1 current is flowing through 1 ohm. At this point current is diverted. By using current divider rule, we can able to find I2 flowing opposite side, so that minus I2. What is the current divider rule? The total current multiplied by other branch resistance divided by total resistance. Here both are 2 only. So other branch resistance, what we need is this 2 ohm. So multiplied by 2 divided by total resistance. Total resistance is 2 plus 2. So I1 into 2 by 4, that is I1 into 2, 1 divided by 2. So minus I2 equal to I1 by 2, half of the current, because both resistors are equal. So the current will be divided equally. Half of the current will be flowing. So I1 by 2. So minus I2 equal to I1 by 2. Half of the current will flow. Now we'll see the further calculation. So I1 equal to V1 by 2. Right? I1 equal to V1 divided by 2. So that minus I2 equal to V1 by 2 into 1 by 2. So we calculated I2 here. Similarly, I1 is nothing but input voltage 1 divided by the resistance 2. So that we will refer the diagram. So this, the current flowing I1 is nothing but V1 divided by 2 ohm. I equal to V divided by R. Based on that, this formula is written. So that minus I2 equal to this I1. Replace this I1 by V1 by 2. Already here 1 2 is available. So minus I2 equal to V1 divided by 4. Bring this V1 in the denominator. I2 divided by V1 equal to minus 1 by 4. This I2 by V1 is nothing but Y21. Transfer admittance. Minus 1 by 4 mho. That is the admittance. That is minus 0.25. The value is minus 0.25. Right? So we calculated the I2, then for I1, in that I1, this V1 value is substituted, V1 by 2, this I1 is replaced by V1 by 2, then we calculated the value. So the first step, we short circuited the output port B dash. By finding Z equivalent, we calculated Y11. By calculating I2 value, we calculated Y21. So this is nothing but 0.5 mho. This one minus 0.25 mho. Now we'll go to the another two parameters by making the input port is short circuited, AA dash. So now the input port A dash is short circuited and the network is shown. This input port is now short circuited. This current I1 is flowing, here I2 is flowing. The next parameter is Y22 equal to I2 by V2 by making V1 equal to 0. Now cross multiply this. V2 equal to I2 divided by Y22. Y22 is 1 divided by Y22 is nothing but impedance. Right? The equivalent impedance, similar to the previous case. By finding the Z equivalent, we are able to find this parameter Y22. What is the Z equivalent? You have to refer from this side. This side is short circuited. You have to refer from this side. So what happened here? So these two are in the current is flowing, is diverted here. Here the current is diverted here also. So this 1 ohm and 2 ohm is in parallel. That is in series with the 2 ohm. Right? Thereby that value is parallel with the 4 ohm. First we will find these two are in parallel. 1 ohm and 2 ohm are parallel. So 1 into 2 divided by 1 plus 2 plus this 2 ohm. So that is the equivalent resistance of this network. 4 ohm, remaining 3. Equivalent resistance of the remaining 3 resistor is this one. 1 ohm and 2 ohm are in parallel, that is series with the 2 ohm. So it is 2 by 3 plus 2. So while taking the LCM it is 3, 2 plus 6. So 8 by 3 ohm. That 8 by 3 ohm is parallel with the 4 ohm. So 8 by 3 into 4 divided by 8 by 3 plus 4. So what is the value? 32 divided by 3. Here divided, taking the LCM, 8 plus 12 by 8 plus 12 by 3. So what happened here? 32 divided by 3. Here 3 divided by 20. We'll go into numerator, it is reciprocal. So 3 got cancelled. Here this 8 is going to 5 times. We'll take the 4 table. 8 times 5. So 8 by 5 ohm. So the equivalent impedance of this network is 8 by 5 ohm. Right? First these two are in parallel. That is series with 2 ohm. That value is 8 by 3. That resistor is parallel with 4 ohm. That equivalent resistance is 8 by 5. So V2 equal to I2 Z equivalent. V2 by I2 equal to Z equivalent. So Y22 equal to V2 by I2 is nothing but 8 by 5 mho. Right? So the Z equivalent what we calculated is 8 by 5 mho. So V2 equal to I2 Z equivalent. V2 by I2 equal to Z equivalent, that is 8 by 5 mho. But what we need is I2 by V2 is the Y22. Y22 is I2 by V2. So take the reciprocal on both the side. So that 8 by 5 now become 5 by 8 mho. So Y22 output admittance is nothing but 5 by 8 mho. So in this problem we calculated the Z equivalent. From that we can easily calculate the Y22 value. Now we'll go to the next parameter. So the network is drawn again. So input port is short circuited. This is the output port. The resistors are available. What we need to find? Y12. Y12 equal to I1 by V2. This one we need to calculate, I1 by V2. For that what we need is current I1 is needed. Right? We need to find this current I1. So here the I2 is flowing. At this point the current is diverted. Again at this point the current is diverted. So we will take this is I2 dash. The current flowing in the 2 ohm. After divert it is I2 dash. This I2 dash is again diverted into this 2 ohm and 1 ohm. This I1 we will take, this is the I1. So by using current divider rule at this network we are able to find I1 value. Right? So if the current divided in the two network, two nodes, so the current is diverted here. We will take this I2 dash. This is I2. After diversion we will take I2 dash. I2 dash is again diverted. That will take I1. The current flowing through this 1 ohm is I1. So the I1 equal to I2 dash, because it is flowing opposite direction, minus it is a total current at this point. This is the total current. I2 is the total current at this point. So the opposite side resistance 2 ohm. What we need is 1 ohm, current flowing through 1 ohm. So other branch resistance 2 divided by total resistance. So it is minus I2 into 3 by 5 into 2 by 3. Now this I2 dash is replaced by I2. That another calculation is available here. Now we need to find the current through this 2 ohm and 4 ohm. Right? For that we are making these three. We are finding the equivalent resistance of these three circuits, these three resistors. What is this? this 1 ohm and 2 ohm are in parallel, that is series with the 2 ohm. So that calculation is available here. 1 ohm and 2 ohm are parallel because it is current diverted. That is series with this 2 ohm. So 2 plus 1 into 2 divided by 1 plus 2. These two are in parallel, that is series with the 2 ohm. After simplification we got 8 by 3 ohm. So these three resistors are now simplified, that value is 8 by 3 ohm. Now we have only two resistors. So this is nothing but current is diverted here, I2 dash. What we calculated I2 dash we can able to find from this circuit. So the I2 dash equal to I2, the current through this 8 by 3 ohm equal to total current multiplied by other branch resistance 4 ohm. What we need is 8 by 3 ohm. So other branch resistance 4 divided by 4 plus 8 by 3 total resistors. So by simplifying this, what we got, I2 dash equal to I2 into 3 by 5. This I2 3 by 5 is substituted here. I2 dash equal to I2 into 3 by 5. So after simplification we got I1 equal to minus 2 by 5 I2. Right. So what we need is I1 because I1 is needed. Well, so here we calculated in the two stages. First this portion is calculated, then after simplification this portion is calculated. Now we'll go for the further simplification. So I2 equal to V2 divided by Z equivalent, that is V2 divided by 8 by 5, that we already calculated. 8 by 5 calculated in the previous parameter. So it is 5 by 8 V2. I1 equal to minus I2 into 2 by 5 from this equation. So that can be written as we cross multiply this side. Minus 5 by 2 I1 equal to I2. We'll make these two numbers that side. So I2 equal to 5 by 8 into V2. This is another formula that we already is available here. I2 equal to 5 by 8 V2. I2 equal to minus 5 by 2 I1, that also available. Now substitute this I2 as minus 5 by 2 I1. Now simplify this. 5 got cancelled and 2 and 8 is simplified. So minus I1 equal to 1 by 4 V2. Here one I2 available, here one I2 available, that is substituted here. After simplification we got this. We'll go for further simplification. So minus I1 equal to 1 by 4 V2. Bring this V2 in the denominator. My I1 by V2 equal to minus 1 by 4. This I1 by V2 is nothing but Y12. That is equal to minus 1 by 4 mho. That is 0.25 mho. So now we calculated all the four parameters. So the describing equation of admittance parameter is I1 equal to Y11 V1 plus Y12 V2. I2 equal to Y21 V1 plus Y22 V2. So we calculated all these four parameters. Y11 is 0.5, Y12 is minus 0.25, Y21 is minus 0.25 and Y22 is minus 0.625. So all these four values are calculated. So our aim is to find the admittance parameter that are calculated. First two parameters are calculated by making output port is short circuited. Remaining two parameters are calculated by making input port is short circuited. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.